Hi learners, welcome. In this video, I'm going to explain about hydrogen bond. Let's see what is hydrogen bond. Hydrogen bond is formed when hydrogen is bonded with electronegative elements such as nitrogen, oxygen, and fluorine. If you see electronegative difference between hydrogen and the other elements, so the electronegativity difference you can see here. Hydrogen electronegativity is 2.20. Nitrogen electronegativity is 3.04. Electronegativity is expressed in Pauling scale. You know that. Oxygen is 3.44 and fluorine is 3.9. So these three elements are having high electronegativity. So when hydrogen is attached with either nitrogen or when hydrogen is attached with oxygen, when hydrogen is attached with fluorine. So here when they attached, what is the meaning of that bond? It's a pair of electrons. Okay. So when because of more electronegativity difference, they will pull bonded pair of electron towards themselves. So then what happens? Because of this reason, hydrogen will get a partial positive charge and there will be a covalent bond between them. Oxygen will get or oxygen or nitrogen or fluorine, whatever the elements you take, they will get a negative charge. So this is said to be charge separation. So in this case, the same thing I explained here. So when because of electronegativity difference, what happened now? Bonded pair of electrons are pulled towards nitrogen, oxygen, and fluorine elements. Due to the unequal sharing of electron pair, hydrogen gets partial positive charge, and another element will get partial negative charge. The other element will get partial negative charge. So due to this reason, charge separation will take place. Now between hydrogen of one hydrogen and other element of other molecule, there exists attractive forces because they both are oppositely charged. These attractive forces are said to be hydrogen bond. Let me show you how the hydrogen bond will form here. Okay, so this is hydrogen, this having partial positive charge and fluorine partial negative charge. Another molecule of hydrogen fluoride you take, hydrofluoric acid, this will get positive charge, this will get a negative charge. Now you can see here between these two, because it is a negatively charged one and this is a positively charged one, there exists attractive forces. These forces of attractions are said to be hydrogen bond. So hydrogen bond is generally indicated with dotted lines. Always hydrogen bond is indicated with dotted lines. If it is a solid line, it is a covalent bond. If it is a solid line, it's a covalent bond. So now you can see how between a partial positively charged hydrogen and negatively charged fluorine of other molecule, there exists hydrogen bond. Okay. Now hydrogen bond is having direction because we are showing from where to where this bond is forming. So just like covalent bond, it is also a directional bond. The strength of hydrogen bond is generally in between covalent bond and van der Waals forces. Covalent bonds are more stronger than hydrogen bond and van der Waals forces are weaker than hydrogen bond. Now let's see what are the types of hydrogen bonds. There are two types of hydrogen bonds, intermolecular and intramolecular. Intermolecular means the hydrogen bond is formed between two molecules. It's said to be intermolecular. Example, you can take hydrofluoric acid, water, ammonia, etc. Whereas intramolecular hydrogen bond means the bond that formed within a molecule. So let's see one example for intermolecular and intramolecular. So you can say this is an example for intermolecular. So first one here, whatever I gave you is an example of intermolecular hydrogen bond. Now let's see intramolecular also. Intramolecular hydrogen bond. Example, ortho hydroxy, ortho nitrophenol I'm going to take, not nitrophenol. In this case, if you see, this oxygen will get a partial negative charge, this will get partial positive charge because hydrogen is attached to highly negative oxygen. Here oxygen is attached to highly negative nitrogen. Now between these two, you can see here between partially positive charged hydrogen and negatively charged oxygen, there exists a bond. This is said to be intermolecular hydrogen bond. So, intramolecular hydrogen bond. And what type of bond is this? This is intermolecular. You can see this is one molecule and this is one molecule. Between two molecules, you can see a bond, hydrogen bond. That's to be intermolecular. Here it is a single molecule. Within a molecule, also there is a possibility of having hydrogen bonds. So that's all the types of hydrogen bonds, intermolecular and intramolecular. Now let's see what are the applications of hydrogen bond. Due to the presence of hydrogen bond, water acts as a universal solvent. So acts as an universal solvent. The reason is, because of hydrogen bond, water will create a polarity and it will be in liquid state and it can dissolve any of polar solvent solutes in it. When hydrogen bond is present, molecules will be come close together. Because of hydrogen bond, what it will do, it will make the molecules come closer. So because of that reason, density of the molecules will increases. Due to hydrogen bond between two strands of DNA are held together. You see in DNA, the two strands are held together because of hydrogen bond. When hydrogen bond is present, melting point or boiling point of the molecule increases because we need to break the hydrogen bond first to convert them into either liquid state or solid state. Vapor state. That's the reason why you have to apply more energy. You need to give more energy. So melting point, boiling point of molecules with hydrogen bond increases. Here I gave you a few model questions on this concept. Why water has high boiling point? The reason is the same again. Here between water molecules, there exists hydrogen bond. Between water molecule, let me show you how hydrogen bond is present in water molecule. Water molecule will be having water molecule is having the bend shape like this, and this hydrogen is attached to electronegatively charged electronegative oxygen. So oxygen will get a partial negative charge, hydrogen will get partial positive charge. Both hydrogens will get. Now when one more molecule comes near to this, will also undergo polarization, partial negative charge. Yes. Partial negative charge, partial positive charge, partial positive charge. Now you can see between two different molecules, this is hydrogen of one molecule, this is oxygen of another molecule. This intermolecular hydrogen bond. Intermolecular hydrogen bond. So in this way, in water, because of presence of hydrogen bond, you can say that generally the boiling point increases. Why HF is in liquid state even though the other it has because of hydrogen bond. Which of the following has strong hydrogen bond when hydrogen is attached to oxygen, nitrogen, fluorine, sulfur? Out of all, fluorine is having more. Fluorine and hydrogen will be having a strong hydrogen bond. The reason is fluorine is highly electronegative out of all elements. Its electronegativity is 3.98 Pauling scale. Okay, that's why. Which of the following compounds have intramolecular hydrogen bond? Water, ammonia, salicylaldehyde, and hydrofluoric acid. We know water is having hydrogen bond intermolecular. Ammonia is also intermolecular hydrogen bond. Hydrogen fluoride is also intermolecular. But salicylaldehyde is an example for intramolecular. Why? Because here you see salicylaldehyde will be having OH and CH. So here oxygen will get a negative charge, hydrogen will get a positive charge between these two. there exists hydrogen bond. Which is what type of bond it is? It is intramolecular hydrogen bond. Intramolecular hydrogen bond. So, answer for this question is salicylate. H2O is liquid while H2S is gas. Well, H2O is having hydrogen bond, whereas H2S doesn't have hydrogen bond. The reason is sulfur is a heavier, bigger element. So that's the reason why it doesn't form any hydrogen bond in this. Okay, so that's all about hydrogen bond. Hope you understood everything. Please like, subscribe, and share. Thank you for watching.